Hello, I'm Professor Ted Brown, and this is my co-professor, Michael White. Today we're going to teach you about exoplanets.
Exoplanets are planets that orbit a star other than our own sun.
But how do we know exoplanets are there?
One way we see exosolar planets is through direct detection, but this is not a very good method because there are several obstacles which are simply too substantial even for these instruments. The separation between the extrasolar planets and the star is minuscule compared to the distance between stars. A star like the sun is about 1,000,000 times as bright as the reflected light from any extrasolar planet orbiting it. Telescopes also blur the light from stars because of diffraction. Thus, extrasolar planets are simply too near their much brighter parent stars to be directly imaged from interstellar distances.
A more accurate way to detect exoplanets are by indirect methods. Astronomers have had a better success at indirectly detecting extrasolar planets. Instead of detecting the planets, they infer its existence by observing the effects that it has on its parent star. Remember that both the star and the planet move around a common center of mass. Astrometric methods, radial velocity methods, and transit methods.
One way to detect extrasolar planets is with astrometric methods. This means to look for the motion of a star or when it wobbles about the center of the mass. Imagine looking at a small planet orbiting far, far away. Occasionally, the planet might pass in between you and its star, briefly blocking some of the starlight. If this dimming happens with enough frequency, you might be able to infer the persistence of the planet, even if you can't see it.
Another way to detect extrasolar planets is with radial velocity methods. This means to look for the periodic Doppler shifts in the star's spectral lines as it moves about the center of the mass. A blue shift, yielding a negative radical velocities when the star is moving towards the Earth. A red shift, yielding positive radial velocities when the star is moving towards the Earth. And no shift when the star is moving perpendicularly to the line of sight.
Another way to detect extrasolar planets is with transit methods, which means to look for the drop in the star's brightness as exoplanets cut across its disk along our line of sight. Where can I see some extrasolar planets?
There is also KELT, which surveys transiting exoplanets around bright stars. The initial public release contains 300,000 light curves in the field of NO2 and NO4. There is Kepler, the first space mission to search for an Earth-sized and smaller planets in the habitable zone of other stars in our neighborhood of the galaxy. And SuperWASP. This 2004 to 2008 release of WASP survey contains nearly 18 million targets.
That's all you know about exoplanets. See you next time.
Yay!